The third soil phase that controls magnesium and calcium are mineral phases. And there are actually primary mineral phases and secondary mineral phases in the soil. And sometimes they look identical and sometimes they don't. So the primary minerals for magnesium, for example, are biotite. These are micas, or magnesium silicates. These are serpentines or hornblendes. And the primary minerals for calcium are calcium phosphates like apatites. They could be hydroxyapatite, they could be fluorapatite, or calcium feldspars. All right, these are calcium aluminosilicates, or they can be calcium carbonate or limestone, which is calcium carbonate. The primary minerals will, due to weathering, dissolve and reprecipitate as secondary minerals. And we'll talk a little bit more about secondary minerals on the next slide. Regardless, primary and secondary magnesium and calcium containing minerals, they both can dissolve to supply magnesium and calcium to the soil and to plants. Typically, primary and secondary calcium and magnesium mineral phases provide a relatively long-term supply of magnesium and calcium in our soils, except if you are in soils that are highly weathered, and we will illustrate that in this video. So, for example, primary and secondary minerals likely have been completely removed from soils that are highly weathered. And again, we are going to illustrate that in this video to drive home the point. So let's talk a little bit about secondary minerals. The secondary calcium minerals that we can find in soils are calcium carbonate. That was actually a primary mineral, but this can, in a primary mineral phase, can dissolve and reprecipitate as calcium carbonate. We can find calcium sulfate. This is gypsum. That's a secondary mineral. Or we can find dolomite, calcium magnesium carbonate. That's a secondary mineral. In terms of magnesium, we can find dolomite, or we can find clays that are present in our soils that contain magnesium. And you should remember this, or this should flip on a light bulb, that this is something we discussed when we talked about isomorphic substitution, that magnesium can replace aluminum in the crystal lattice of 2-to-1 type clays. And thus, magnesium may be present in 2-to-1 type clays. And believe it or not, 2-to-1 type clays do weather over time to form 1-to-1 type clays and release magnesium to the soil. These secondary minerals also dissolve, and they also precipitate or reprecipitate. It's all dependent on soil pH and the concentrations of calcium and magnesium in the soil solution. And if the concentrations in the soil solution are high, these minerals won't dissolve because there's no place for calcium and magnesium to go. But these secondary minerals dissolve and precipitate, and over time supply magnesium and calcium to our soils to feed plants. So I want to drive home the point of chemical or mineral weathering. So this is a diagram that shows you a number of different mineral phases that are found in our soils. Here's the chemical composition or formula of all those minerals and the general weathering scheme that occurs over eons in our soils, right? And so the mineral phases that are near the top of this diagram weather relatively easy, and the minerals at the bottom weather almost impossibly. Eventually they will weather and be removed and our soils will just be gone. So if I start at the bottom, soils that contain gibbsite and hematite typically look pretty red. They're found in very tropical environments. Soils that contain quite a bit of kaolinite, that's a 1-to-1 type clay, are found in highly weathered soils like those found in the southeastern part of the United States or the southeastern part of China, for example. But look what's at the very top of this slide. The top of this slide contains calcium and/or magnesium mineral phases that weather essentially first from our soils. And so this is one of the main reasons why over time we need to add calcium and or magnesium back to our soils. It's simply due to the weathering and the removal of primary and secondary mineral phases that contain both calcium and magnesium in our soils.